Well, hello there. So today I'm going to talk about Arduino libraries for our Mechatronics class. These examples are all from this tutorial on the Arduino website. And I have to say that um, if you're okay reading things, it's really well written and it goes into more detail than I'll probably put in this video. So I highly recommend you just read this tutorial if you can learn that way. If you want to see something presented, that's what this video is for. But I think it's a really nicely written tutorial, so I do highly recommend it. The scenario is you work for a company and you write software for them, and you wrote Morse code functions. So here you can see a program. It's got the usual setup and loop. And in the loop function, we're calling dot, 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 dash, 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 dot, dot, dot. That's doing SOS in Morse code. And there are functions for dot and functions for dat, dash, that turn a pin on and off and blink the Morse code. So someone else in your company says, oh, these are great, we're going to use Morse code in every one of our products, and we don't want to have to reinvent the wheel every time, so can you make these a library that we can share with all of our employees and make this code very modular? So making a library is making a class, a C++ style class. It's an object-oriented programming style. And so that's what we're going to do, is take this program that's not using a library and make a library to package up all of the reusable parts. So once we're done, you can use that library, and to use a library we just use the pound include up here and the name of the library. So we're including our Morse library that we'll go into, and our main loop looks much shorter. So we're just calling Morse dot dot rather than dot and dash as separate functions. Now they're part of the Morse library that we declared up here, and I'll talk about that in a second. But the main program is all business, and the definitions here are done in the library. So you could reuse the library in other projects. You do have to pound include to make sure that you get that up there. And the C++ class that this is part of, all of this, it's similar to a structure that we looked at in the last lecture, where a structure lets you bundle up a lot of data into one thing. A C++ class lets you bundle data, variables, as well as functions, and it has initialization properties too. So it's a little bit more thorough way to bundle up things that all work together in a program. You've probably already used these kinds of things. If you use serial.print and other statements like that, then you've already used classes. So just looking at this, it's the same program. We're looking at it again. Inside the library, we have this new variable type. So we have Morse with a capital M is a type. It's the class. So instead of int or float, we have a Morse variable. And it's a little unfortunate that it's named Morse with a lowercase m, although that's very common just because the class is capitalized and then the instance of the class is not capitalized, but it makes it hard to talk about. So we have an instance of the capital M Morse class named lowercase m Morse. When we make an instance of the class, we give it some parameters and it uses that to initialize. So this says blink pin 13. We could have a different instance hooked up to pin 10, and then we could do different Morse code on the different pins if we wanted to. So here we're blinking pin 13 when we set this up. When we initialize this with pin 13, it causes a function called the constructor to run. So look for the constructor function when we define our library. So to make a library yourself, I think it's a good practice to start with the code like we saw in the first slide that just had the code with functions, and then make all that work and test it, and then copy and paste into the library files that you need. You need two files to make a library, the .h file or header file, and the CPP, C++ file, are the two files we'll look at. So this is the header file shown here. It's got nice comments at the top attributing the author and other information. And it's basically telling the compiler what our class has. What does it have? So we're saying we want a class. It's named Morse with a capital M, and it's got curly brackets to show how much of the code is talking about this class Morse. And then we're defining variables and we're defining functions. So we've got a function named dot and a function named dash that we used in the original program. Remember, we had these two functions. So we want to put them there again. And then we have a few other things. There's always a function declared here with the same name as the class. That's the constructor. And it has an input that's the pin. So remember, we were initializing our instances of the class with pin 13. So we have a constructor, we have the functions that we need for the library, the Morse code functions, and then we also have an integer. So this is a variable named _pin, and that is a variable where we store which pin we're blinking on and off with the dot and dash functions. So here we're just defining what's there. So we define all the variables, and then we just give names to all of the functions. So we say what their inputs and outputs are and give them names, and we also define the constructor function. The other thing you see up here is this wrapper. So there's this stuff that we always do in a header file for a class. It's pound if not defined Morse _h. Pound define Morse _h. Remember, pound define is like a search and replace, but here we're not actually defining it as anything. We're just defining it to exist. And then end if. So this just keeps us from having this be included in the code more than once, because we pound include this file, and it's bad if you do it more than once. So if it's already been defined, then it skips this, but if it's not defined, then it defines all of this. The next time you pound include it, it'll say if not defined morse.h, and it'll look and it'll say, oh, it is defined. I can skip this, I already did it. So it's just something we always wrap our header files with, this little preprocessor instructions. And the other one for Arduino is to pound include Arduino.h. That lets us use things like serial.print, and all of the analog to digital and digital pin functions are part of this that are included in a .ino file, but since it's a .cpp file, we have to explicitly include this. So we just are promising here that what we're going to have in our class, but it's the header file, so we don't actually implement them quite yet. So the second file in our library is this .cpp file, and this is where we keep all of our promises. So we have to define all the functions. All the variables were declined in the .h file, and that's all we have to do. But we have pound include Arduino.h again, we've seen that before, and then we pound include Morse.h. That's the one that we just looked at, where all of our declarations were made. And then we keep all the promises. So we said we were going to have a Morse with a capital M function with an input of a variable named pin that's an integer, and that's the constructor. And all of the function names have to be connected to the name of the class with the name of the class and then 2 colons. So we just sort of follow that boilerplate template in all of our function definitions. So if we look at the H file, we said we would have a Morse function, the constructor, so we would have a dot function and a dash function. The constructor is where we're connecting the library instance, where we say we want a version of Morse that's connected to pin 13. And so we've passed 13 in as pin. That's a local variable because it's an input to this function. And so _pin, that was a variable in the header file. And so by setting this into the class variable, _pin, all the other functions can use _pin. So that's 13 in our one instance. And so here we're using that here. Okay, so in the header file, this is where we set up underscore pin. So just kind of circling back, we're using that. In the constructor, we pass it the pin number, and then this is a variable that's part of the class where we save it for everyone else to use it. Public means that in your main program that calls the function, you'll be able to access the constructor and dot and dash, because the Morse code people want that. Private here means that the functions in the class can access it, like dot and dash can read what's stored in here, but anybody using the function can't access underscore pin, can't accidentally change it. So by making this private, we make it so that it's initialized here, but you can't accidentally mess things up. So the class user can't see the underscore pin. If it was public, we could do something like Morse dot underscore pin and it would work. But because it's under the private variables, it won't work. Back at the C++ file, the CPP file, again looking at underscore pin. So we pass 13 into the constructor and it takes that and stores it in our class variable underscore pin, and then it's private, but all of these functions here can use it. So underscore pin is used when we're using digital write to turn the pin on and off. So the constructor defines it, and then all the class functions can see it. So then we have those two files, the .h and the .cpp file, that we have to keep with us, and that's what you're going to distribute. So at your job, where you're writing Morse code for all of your devices that you're manufacturing, you give the .h and the .cpp to your coworkers. And the easiest thing to do is to just put it inside the same folder with your .ino file. So here's a look at my folder, and that will all work nicely with Arduino if you just put them all into the same folder. That way you have to have multiple copies though if you want to use this in more than one project. So if you want to put these where you can store one copy, there are other library files that are stored in your Arduino compiler directories, and so if you look at the tutorial, they'll walk you through how to do that. That tutorial also talks about how to set up the Arduino system so that things like the class names change color like they do in the regular Arduino IDE. So if you want to really get this to look like a professional library, you can see the tutorial. And then if you distribute this library as a download, you can also write your own examples. So if you add a library to your Arduino system, like the liquid crystal library that comes with the Arduino development system, it's a library, it's a .h and it's a .cpp, and it also has examples. So if you really want to make a professional Arduino library, you can bundle examples with your system and put them all in the right directories too. So you can decide how much effort you want to put into making this a permanent reusable library, or just copy them into the folder for this one time. Okay, so the last thing here is an example. This is from an old final exam from our class. And so over here on the left, we have the main program with, that's the eno file called final lib eno. It includes this thing called hilo.h. So we have hilo, the name of the class, and mycomper is the instance of the class using pin 13 and A0. Because this calls the constructor, that's all the initialization thing, we don't need anything in setup. And the loop just calls one of the functions in the class and delay. And then here we have the .h file and the .cpp file. So the .h file, remember, is telling us what's in the library. So this is kind of the, you can use this as documentation or to have a top level look at what's going on. So public, we have the constructor, and we have a function named comp, and that's what we're calling over here. Private, we have two integer variables, underscore pin and underscore ANDC. And then in the CPP file, we have the constructor, hilo, same name twice. Then we have the comp function defined here. The comp function has a local variable named dodo, and it uses the analog read from Arduino. And if it's greater than 500, it turns on a pin. Otherwise, it doesn't turn it on, and pin comes in here from the constructor. And the analog pin also comes in from the constructor, there and there. So you can see it's very similar to the Morse code example. It does similar kinds of things, similar setup. And so the question for you to wrap up this video is, if we ran that program and we connected a voltmeter to pin 13 and ground, and we connected pin analog 0, A0, to 3.3 volts, this wiring, what voltage are we going to measure on pin 13? So to get that one answer, you're going to have to think through how the program works, what voltages can come out on these kinds of pins, and what values you get from analog to digital. So it's a lot of synthesis going on. That's why it was a final exam problem. That's going to be the quiz for this lecture. Good luck, and I'll see you in the next video.